Good morning. Today we're going to start our new unit on modeling using functions, and we're going to start with the absolute value function. Um, so the very first thing I want to do is just do a little review on some of the things we've studied so far because we have a midterm coming up in about 2.5 weeks, and it's a good idea to start looking at some of the previous concepts that we studied, especially the ones that cause the most struggles on the tests and that are most likely to be on the midterm. So the first question is, what is the equation of the function that has roots at -2, -1, or -2, -3, and +1? So those are important points. And the point at -1, -8. So to find the equation that has roots, we first have to set up that go through this point, that has these roots that goes through this point. We need to first set up a general equation using these three roots and making those into factors. So we have y equals some number a, which we're going to use the point to find a, of x, and you take the opposite of these numbers to make them into factors, make the roots back into factors. So x minus 1, x plus 2, and x plus 3. Now we need to solve for a. So we're going to take our x and y, so this is the x value and this is the y value, and substitute those into this equation. So we have 8 equals a times -1 minus 1 times -1, because x is -1. This minus 1 is part of this factor already. So -1 plus 2 and -1 plus 3. And then we have to simplify these. So -1 minus 1 is -2. -1 plus 2 is 1. And -1 plus 3 is 2. So now I have 8 equals a times -4. Well, I'm just going to divide by -4 on both sides. And a equals -2. This was -8. So a is +2. Okay, now that I know a is +2, I can go back and substitute that number back into the original function or equation. So this number here is going to be 2. So I write it out. Y equals 2 times x minus 1. Now I put the x back in instead of the -1. X plus 2 and x plus 3. And then we multiply these three factors together, and then that answer gets multiplied by 2. So first I have x minus 1 times x plus 2. It's x squared minus x, 2x, and -2. So when I simplify this is -1x. These two things get added together to make a +1x. So I have x squared plus 1x, or just x, minus 2. And I have to multiply that times that last binomial, x plus 3. So when I multiplied these two together, I got this. This needs to be multiplied by this, so x plus 3. So x cubed, x squared, -2x, 3x squared, 3x, and -6. So now I have to figure out what that equals and multiply that by that 2, and then I'm finished. And this seems like a lot, but none of these steps are anything that you've never done before. Everything in here you've done before. Is just putting it all together makes it seem way more complicated than it is. So I have y. So the last step, y equals 2 times x cubed. 3x squared plus x squared is 4x squared. 3x minus 2x is 1x, or just x, and then minus 6. So now my final answer, everything in here gets multiplied by 2, because I have a 2 in front. So 2x squared plus, or 2x, that should be cubed, 2x cubed plus 8x squared plus 2x minus 12. So there's the answer to that one. Now, the second equation, you might want to pause because if you're still copying this down, pause your thing because I'm going to erase or you're going to end up having to go back because I'm going to reset this. Okay, so the second question on here is what is one root of the equation of this equation is 2. What are the other two roots? Well, if I know one of these, the roots is 2, there's two ways you could do this. You could just put this in the calculator and see what the other two roots are, or you could put 2 in the box and use synthetic division using the coefficients 1, 2, -5, and -6. Bring that 1 down, and you should get a 0 here. So the answer is x squared plus 4x plus 3. Set that equal to 0 and solve this. And you can solve this either by factoring or the quadratic formula. In this case, you can solve this one by factoring. Factors of 3 that add up to 4 would be 3 and 1. So this is x plus 3 times x plus 1 equals 0. And x equals -3 and -1. So that would be your answer. Okay, so you're going to go to your notes, and we're going to start just by doing a quick review of what absolute value is. Absolute value is just, if you think of a number line, it's the distance from 0 on a number line. So the number inside the absolute value bars or expression is a distance from 0. So we want to know what distance this value is from 0 on the number line. So if I were to make a number line, good old-fashioned number line, and go to -2 and 2, we'll start with 2. Well, the distance is how many units from 0. So if it's a number of units, that is always a positive number. Okay, and the distance from 0 of -2 is also 2 units. So that's why the absolute value is always a positive number, because it's a distance, and a distance is always positive. So the general form of an absolute value function is, if you recall from our first week of class, is a times x minus h plus k. And you might notice this looks very similar to the quadratic vertex form of a quadratic function, and it is. And these two functions have a lot of similarities. The difference in this unit from the previous unit, our inverse unit, we're going to include all the values of the domain, because we're not talking about finding an inverse function that has to be one-to-one. The function does not have to be one-to-one. So when we start talking about domain of an absolute value function, we're going to include all real numbers, whereas in the last unit we cut off half of that domain to make the function one-to-one. Now, if you remember, in the absolute value function, these two numbers hk gave us the vertex, and it does also in the absolute value function. So the quadratic function hk was the vertex, and in the absolute value function hk is a vertex. And I'm going to skip transformations for now and go down to domain. The domain is just all real numbers. So -infinity, x is between -infinity and +infinity, or just infinity. Okay, but the range is based on this number k. Because if you remember, if you'd graph an absolute value function, like the parent function of an absolute value is right here at 0, 0. Okay, so there's a lowest value in the domain, or if it were an upside down absolute value function, there would be a highest value in the domain. So depending on whether this number a is a positive or negative number, you will have a lowest or a highest value in the range. So the range, if a is positive, then the range is just y is greater than or equal to that number k. If it's a negative function, a function that has been reflected over the x-axis, then your y's are going to be less than or equal to k. So it all depends on whether this number is a positive or negative number. If it's positive, your domain is going to be all the values above k. Your range is going to be all the values above k. And if it's a negative number, the range is going to be all the values below k. Now, we also did a little review of transformations of these functions. And again, what we just had up here was the parent function of the absolute value. So I'm going to leave that up here. And it just looks like this. And when I start doing things like changing the number inside to some, adding or subtracting a number from that x, then your vertex is going to move left or right. And if I start adding a k on the outside, your vertex will move up or down. And you also have this number a that just helps you decide whether there's any dilations or any reflections over the x-axis. Well, in this case, that means if a is, again, positive, then there's no reflection. So I guess I don't need to write that. Never mind. If a is negative, there's a reflection over x-axis. If a is negative, so that means it's less than 0, this reflects over the x-axis. And if that a, the absolute value of a, so we're just talking the value of a, the positive value of a, if that's greater than 1, we call that a vertical stretch. the graph gets narrower. And then if absolute value of A is less than 1, it's a vertical shrink. The graph gets wider. Okay, now we also have our translations. So I'm just going to draw a little line here because we're going to take more room. And make that little table like we made on our little note card. So remember, you have inside the function and outside the function, and you have either add or subtract. I'm going to abbreviate subtract. Okay, so if it's inside the function and you add, the function shifts left. And if it's inside the function and you subtract, the function shifts right. And if it's outside the function and you add, the function shifts up. And if outside and you subtract, the function shifts down. So for instance, if you had y equals absolute value of x plus 2 minus 1, we have a 2 inside and it's positive. So add inside, you have a left shift 2, and you have a minus 1 outside, outside subtract, you have a down shift 1 unit. And then let's say I put a number in front of here that was a negative. That means you have a reflection over the x-axis. So that's what we mean by these transformations. And if this number was a 2, then it would be a narrow or vertical stretch. If it was a 1/2, it would be a vertical shrink. Okay, so what are the vertex transformations, domain and range of f of x equals absolute value of x minus 2 plus 5? Okay, so I want the vertex. The vertex is hk, and remember h is going to be the opposite of this. So this is minus 2. H is going to be plus 2. So vertex, it's 2. And then k is whatever this number is, and it's positive 5, so it's 5. Transformations. There's no A, so there's no dilations or reflections, but there's a left or a minus 2 inside. So inside subtract, that's right. So I have right 2, and there's a plus 5 outside. So if I add outside, I move up. So this is moving up 5. And then domain is going to be all real numbers. And then your range is, this is a positive function because excuse me, a is 1, and so we've got a plus 5 on the outside, so k is 5. So y, all your y's have to be greater than or equal to 5. Okay, that's it. So I want you to try the next one. So pause the video, try the next problem, and then come back. Okay, so this one, this is a is negative 1, because there's a negative in front with no number there, so that means it's negative 1. H is negative 1, because it's the opposite of this number. And k is negative 3. Okay, so that's what we need to do the transformations. And the vertex. Vertex is negative 1, negative 3. Transformations. A is negative 1, so we reflect over x-axis. And then h is negative, or we have plus 1 inside. So plus 1 inside, add inside. If I add inside, I go left, left 1. And if I subtract outside, that's down 3. Your domain is all real numbers. And your range, again, the domain is always going to be all real numbers for an absolute value function. We're not doing any inverses. So, and your range is based on this number k and a. Well, we know a is negative, so this is a flipped or a reflected over the x-axis, which means it would look like this. It's moved, but let's just take the parent function. It's reflected over the x-axis. That means there's a maximum right here. So all your y values have to be below that maximum. So all your y values have to be less than or equal to that -3, the maximum y value. Okay, so the next thing we're going to do is take the first function we just looked at, absolute value of x minus 2 plus 5, and graph it. So we remember the vertex is 2, 5. So I'm going to think about that vertex. I don't want to do that. And make a table of values. Well, if I want to make sure I have the vertex on my function, I know I have 2, 5 on my function. 1, 2, 3, 4, 5. I'm going to look at the x-axis. So to the left of 2, I have 1 and 0. So I want 0, 1, 2, and then to the right of 2, I want 3 and 4. Well, I know when x is 2, y is 5. If x is 0, now you can put this function right in your calculator and find out these values. If x is 0, y is 7. And if x is 1, y is 6. And how to put this in the calculator? You'll go to y equals, and then you'll hit math, num, number 1. That's how you graph it. And then if you want to see the table, you'll hit second graph. Excuse me, I don't want to mess this up. Okay. So if x is 3, y is 6. If x is 4, y is 7. So I had 2, 5, and 0, 7, 1, 6, 3, 6. Notice how these y values are repeating. It's because it's a symmetric function like the quadratic. And there's your graph. So again, if you want to put this in the calculator, let's see what that looks like. So we're going to go to the y equals menu, close that or clear that. You want math, and I want to go to num. So I use the cursor to do that, and I want the first one on there, the absolute value. And then I put, it was x minus 2 plus 5. X minus 2 inside, use your cursor to get out, and then it was plus 5, plus 5. And then you don't really need the graph, you just need the table. So hit second graph, and then you get your table. And if you need to move up to see more x values, you just use your cursor. And we can see that when x is 0, y is 7. When x is 2, y is 5. It looks like I've got my table set funny here. Oh, because it's on ask. Let's go back there now. Now we can see x is 0, y is 7, x is 1, y is 6, x is 2, y is 5, x is 3, etc. So you can see your values. Okay, second one. We have to go back and see what that function was because we want to graph this function now. So negative absolute value of x plus 1 minus 3. Negative absolute value of x plus 1 minus 3. That's the function we're going to graph. So make a table. And remember your vertex in this one was negative 1, negative 3. So let's put that, we go negative 1, negative 3. Okay, so x is negative 1 at the vertex. So I want 2 points to the left of that. So negative 3. These are the x values, not the y values. Negative 3, negative 2. And then negative 1. The next x value is 0 and 1. And I know when x is negative 1, y is negative 3. What if x is negative 3 and negative 2? Well, if I'm going to go with these two, because I know if I get these two, they're going to be the same as these two. So if x is 0, I have 0 plus 1, which is 1. Absolute value of 1 is 1. I have to make that negative 1. Negative 1 minus 3 is negative 4. Then if x is 1, this will be negative 5. So I have negative 4, negative 5. And again, you can stop this, put it in your calculator, and then go as slowly as you need to. Don't rush just because I didn't stop while you were watching the video. But go ahead and put it in your calculator, check those points, and make a table. Now we're ready to plot the points. Negative 2, negative 4, negative 3, negative 5. And the other way, 0, negative 4, and 1, negative 5. So this was a reflected, remember when we did the first part of this problem, we said it was reflected over the x-axis. Okay, so that's part of your assignment for today. The other part of the assignment for today is to actually take a word problem and set up an absolute value function to go with it. So first, with any word problem, it's important to read and annotate. And you might have to read twice or 3 times, and just have enough patience to do that. Okay, so sunlight reflecting off water contributes to sunburn. Guy is sitting in a boat on a lake with her head about 2 feet, I think this might be important, 2 feet above the surface of the water. Looking at the picture, I can kind of get an idea of what's going on here. The light reflects onto her face from a point 4 feet away. Write and graph a function that illustrates the path of the light. Note the angle of the light with respect to the water is the same for both incoming light and reflected light. Okay, so in your book, they give you a set of steps. In your notes, they give you a set of steps. First is choose coordinates for all points of interest in the problem. So points of interest. Well, I have Guy, and her head seems important, and this reflection point seems important. So how could we do this? First we need to figure out, the first thing you want to do is figure out where is the origin going to be in your picture. Where's that 0, 0? Where's your graph going to originate from? And it seems logical that this point right here would be that point of origin. So we're going to make that our 0, 0. If we make that our 0, 0, we have a negative direction here and a positive direction up to Guy's eyes. So the negative, and it says light reflects onto her face from a point 4 feet away. So this point is 4 feet away from where she's sitting. So if this is 4 feet in the negative direction, this would be negative 4. And if she's 2 feet above the surface, this distance is going to be 2 feet. So we can make that point negative 4, 2. Okay, so there's our important points. And we're supposed to write and graph a function that illustrates the path of the light. So we're starting with some points. You always need some points to write an equation. Create an absolute value function to model the situation. So just like our warm-up, we're going to do like the problem in the warm-up where we wrote an equation. This one's not going to take as long because you don't have to multiply out three binomials at the end. So first we're going to make an equation using this point, and then we're going to find a. So remember, the equation for an absolute value function is a absolute value of x minus h plus k. So it looks like our vertex hk is going to be 0, 0. So this function is going to be a absolute value of x minus 0 plus 0. So really this is just a times the absolute value of x, because you don't really need those zeros in there. Well, how did we solve for a in the problem in the warm-up? We plugged in a point we knew. So we know this point. Let's plug that in. So we've got y, which is 2, equals a times the absolute value of negative 4. Well, we know the absolute value of negative 4 is 4. So 2 is equal to 4a. And then to solve for a, we just divide both sides by 4. This is 2 over 4. That reduces to 1/2. So a is just 1/2. Plug that back into this equation. Okay, we have y equals 1/2 times the absolute value of x. Now we just need to plot the graph. We know the vertex is at 0, 0. Let's go to -1. We'll just do 1 point on either side. Well, let's do 2. I'm going to use, whenever I have a 1/2 in front of there, I'm going to go ahead and count by 2's instead of 1's to get my x values. So I'm going to do -2 and 2. That way, I'm not going to get halves in my y values. You don't have to do that. It's just going to make a prettier graph, or easier to plot your points. So the absolute value of -2 is 2. 1/2 of 2 is 1. The absolute value of 2 is 2. 1/2 of 2 is 1. So to plot your points, you've got the point 0, 0 for your vertex, -2, 1, and 2, 1. So that graph is like that. And it makes sense because remember, it's supposed to get wider when you multiply by a number less than 1. Yeah, so that's what the graph looks like. All right, so you have a worksheet with 4 of the graphing problems, including find domain and range and all the other stuff, and 1 problem similar to this. Just remember to follow those steps, and they give you the steps in the problem. When you read problem 5, don't just look at the top where they have the picture. Look at the bottom where it says, ignoring the barrier for now, graph the path of the ball on the coordinate plane using the hole as 0, 0. If you use the hole as 0, 0, that's a huge hint to get the rest of the important points. Remember to find all the important points. So 1, read and annotate. Find your important points. And then write an equation using those points. Use those points to write an equation. Once you have that, you can answer the rest of all those questions. So that's what you need to do to solve these problems.